Hello, everyone. So John, you set me up really nicely with that talk. Just to say, I've come over from the UK. I promise I haven't brought killer shrimp with me. I didn't know about them, but I'm pretty sure they weren't in my luggage. John set this up nicely. We're going to be talking about a project that's just concluded, and actually the report was published yesterday on the EPA website, where we were looking at investigating the likelihood of really bad, harmful algal bloom events in Ireland's lakes. Just some context. Again, John alluded to this. Lots of you will be aware of the serious problems that have happened at Lough Neagh. In 2023, it was a harmful algal bloom of unprecedented duration, extent, and magnitude. It says there, really, really serious event. And the reason most of you know about it is because it was in the news, or you maybe live locally, but if not, this reached the UK, even reached international audiences. So levels not seen since the 1970s, Guardian reporting that it's dying in plain sight. You know, these are really serious headlines. There's reports of protesters calling for action, as well as people holding a wake for the loch. You know, it's slow death by algae. And then the eel fisheries potentially collapsing as well, reports from fishermen about their industry dying. Those were all from the 2023 event. This was just from last year, so it's still in the news. You know how something becomes really important in the news. Any bloom at Lough Neagh now is probably going to make the news, particularly if it's even slightly prolonged. I think there's two things you can learn from this. Firstly, it's obviously a really serious harmful algal bloom event. It was long, it was big, and it was across lots of the lake. But I think just as important is its impact. So it had that impact on jobs, on the local nature, but also on recreation and on drinking water. And all of that created this public outcry and all of these news stories, which is why I and you have heard about it so much. So in this project, we were doing a few things. We started off with some literature reviews. So we wanted to learn what happened at Lough Neagh, what were the causes of that, what were and are the impacts of the invasive zebra mussel, which John again alluded to being one of the causes, and what's happening elsewhere. What are the current mitigation measures in place? How are they being followed? And what can be done to manage the impacts of harmful algal blooms? So to do that, we were doing an impact analysis. We were characterizing 35 lakes in Ireland, and we were exploring their catchments and their in-lake nutrients and chemistry and assessing whether they've got zebra mussel or how much, as well as looking at climate change and ultimately trying to find out the likelihood and the impact of a harmful algal bloom at each lake. And that led into this sort of defining what we called risk profiles for each of the lake. So it's looking at both that threat of a harmful algal bloom, but also the public and nature amenity value, we called it, for each lake. So if there were a bloom, what kind of impact would it have? What changes would happen at that lake? And who would be angry? And would it make the news? These kinds of questions. So just back to Lough Neagh very briefly. Again, John had this report in his slides, and it really created the three main reasons for the bloom that coming out of this report and a number of others were nutrient loading. So it's phosphorus mainly coming from agriculture and wastewater in the catchment. But also climate change, so increased surface water temperatures, but also increased rainfall and flooding. And it's that flushing of nutrients into the lake, often dry periods followed by lots of rain. Flush those nutrients into the lake and can cause big issues. But also zebra mussel. So the impacts on phytoplankton populations, creating these clear water phases, allowing the sunlight to come down into the phytoplankton. Also the selective feeding on non-algal blooms, so non-cyanobacteria. And again, this slide was in there, but there are many more factors at Lough Neagh. So those three are the main ones, but they identified 18 in the catchment and in lake. For this, we're focusing on those main three. So just quickly, whilst we were doing the project, this special issue of Hydrobiologia came out, and it identifies lots of things about zebra mussel in terms of their impact, so how many there are, where they're distributed, the retention time of the lake and the morphology of the lake, as well as how long they've been there. They're associated with a number of things, so reductions in phosphorus and chlorophyll A, also reductions in phytoplankton, but again, it's that selective feeding that's the problem. So they might reduce the overall phytoplankton problem, but if they just leave the harmful cyanobacteria, that's when a really serious bloom can happen. And the impact is generally greatest in shallow lakes and during the early to mid stages of their invasion. There were a couple of Irish studies as well A particularly interesting one in Lough Neagh where they had an infested and uninfested basin. And some global studies suggest that it's almost like a good thing. So it can improve your water quality, which is fine until you have the most serious harmful algal bloom you've ever had. So lots of mixed pictures there. In this study, we looked at 35 lakes across Ireland. There's their catchments there as well as Lough Neagh and its catchment, selected mostly for either having a history of nutrient enrichment or being of particular national importance, perhaps for their amenity value. Just to say, this project collated absolutely loads of data. We had a really helpful steering group, so we got data from the EPA, from Fisheries Ireland, from DARA, lots of other sources. But it wasn't just the data that's available, which was really useful. It's that knowledge as well. So people's knowledge was taken on board for this project. Not everything is online yet, but we are getting there to some extent. Zebra mussel records and climate data, global climate data models as well, were used in this project. And I'll start by just saying that we just started characterizing all of the lakes. So their morphology, so their area and catchment, as well as some annual chlorophyll A and phosphorus values and their WFD statuses. So we just get a quick idea of what are the lakes like, and are they like Lough Neagh? Are they likely to have similar issues? These are those same values, and coloured in red if they're high and white if they're not. You can see Lough Neagh down there with the red in the first column. It's really, really big. When I flew over from Edinburgh, we basically went over the loch. It's really big. You can't see the other end. And on the satellite image, it's such a dominant feature. But there are really big lakes in Ireland as well, of course. This is a principal component analysis. So we're taking that data and we're putting it onto these principal components. You can see there Lough Neagh circled in red. And essentially, to read this, if there's points near it, they're reasonably similar. So there aren't many in Ireland that have similar. It's just so big. And its catchment isn't huge in comparison to the huge size of the lake. So it's a slight outlier. What can we learn from the water chemistry, though? So perhaps the morphology of the lake, there's nothing quite like it in Ireland. Again, on the left here, we've got all of the things that came out of the literature review in terms of important water chemistry, as well as sensitivity factors. Again, plotting them there is quite a lot to take in, so we've done another PCA there. Lough Neagh, again, circled in red, and you can start to see a few lakes in Ireland clustering around Lough Neagh a little bit. So that's a little bit more worrying that their overall water chemistry is in a similar area to Lough Neagh. But it's not just about chemistry. I've got two graphs here. I'll come back, actually. This is just a summary of Ireland's climate change. I think we had some talks on it yesterday when I wasn't here. So you might have heard this already. But general picture, this is mean temperature. General picture, of course, is that temperatures are going up. The different lines here are different social pathways. So depending on human behavior, what might happen. But unless we're like the perfect humans, then things are going to get worse. And it's about a degree every 20 years or so in terms of mean temperature warming. This is precipitation. Now, it's a crazy picture. In the red, that's all the projected data. So it's not really going up much, but it's going up and down a lot, and each of the projections is very different. What we did is we took that data, chose one of those social pathways, and plotted it for all of our lakes, including Lough Neagh here. So we've got 36 graphs. You don't need to read too much into this other than to see that they're all quite similar. So generally speaking, we've got an upward trend in temperature. Air temperature relates very well to water temperature. So as an upward trend and nothing too dramatically different between the lakes in Ireland. Same thing for precipitation. And initially, this looks like a similar thing. Not much going up in terms of the overall trend, but lots of ups and downs. What you will see is that some lakes have more ups and downs than others, so more extreme events. And it's those that we're worried about in terms of flooding. Lough Neagh, it's in the southwest of the country, stands out. Loads of rain, so quite a different lake. I won't dwell on these, but these are exceedance tables or graphs that are showing, in a way, kind of numbers of record-breaking years above a baseline period. With temperature, you can see it's reasonably consistently getting redder as time goes along the x-axis there. With precipitation, it's all over the place. So I think if one of those things is to worry about, temperature is a reasonably predictable rise. We can work with that. With precipitation, these big flooding events could happen, and they could happen at any time. And just getting on to zebra mussel, I won't dwell on the table. This is just saying whether it's got zebra mussel and when it came in. We used some of the data from John, actually, here. This is a plot of all of the lakes, apart from Lough and Polyfuca, that don't have the mussel. These are the 33 of our 35 lakes with the catchments. merged into the black zone. So firstly, you can see very interconnected set of lakes. But also the yellow striped lakes all have zebra mussel. So the vast majority of the lake area has it. The points, the little crosses, are where individual zebra mussel records have been recorded. Pretty much every lake that could get it either has it or will get it. It's either in the catchment or it's recorded in the lake. Although there isn't a huge amount of data here, so maybe we can work together to try and get more records, more people recording, so we get an idea of population change. We also did some catchment assessments. So this is taking data from the EPA, another great resource, loads of really good catchment data sets and reports. This was looking at the significant issues and pressures on all of those lakes, as well as the sub-basins and basins for the WFD and land cover. For phosphorus, we were looking at where the phosphorus is coming from in the catchment, the total load, and the types of sources for each of the lakes, as well as the target agricultural measures for mitigation. This was the key thing next in terms of looking at the value for the public and nature amenity. So things like the protected area statuses, whether they're bathing waters or drinking water lakes or salmonids, and different types of protected area as well. And then we looked at how many people were in the catchment. So if there's a problem, how many people are likely to be affected. And finally, we had a quick look at the programs of measures that are in place, as well as looking at their level of uptake and how they might respond to a prolonged, serious, harmful algal bloom, like in Lough Neagh, which we perhaps haven't had in Ireland. And finally, looking at the WFD priority areas for action. I won't go too far into this, but just to say all of our lakes across the bottom there. These are the catchment assessments. So this is just different land covers, reasonably consistent, dominated by pastures across the lakes we were looking at, and perhaps across most of the major lakes across Ireland. A few a little bit different, but most of them reasonably similar in that sense. This is phosphorus load per area for all of the lakes, all reasonably high. A lot of phosphorus is coming in. You get high catchment loads in these lakes in Ireland. The lowest and the highest, lowest is double it to the highest, I think, roughly. But yeah, and changes, obviously. It depends on the lake a little bit. And this is the sources of the catchment. So again, reasonably dominated by that pasture. But you do see differences. I think it's Enel, is it? That's got all sorts. It's just got a little bit of everything. And then you have lakes that are dominated actually by the lake themselves. So some have really small catchment compared to the lakes. So we just got an idea of the different catchment makeup. Now, we've done a lot of data analysis there. We've collated a lot of data from a lot of sources. In terms of judging the threat of harmful algal blooms, we wanted to look at certain metrics. We ended up with 11 here. So lots of the things I've gone through, its similarity to Lough Neagh, whether it's got a history of nutrient enrichment, its current statuses in WFD, whether it's got zebra mussel, whether it's deep, because if you've got a shallow lake, it's got more problems for lots of things, actually, for legacy phosphorus, for the zebra mussel as well, and then the retention time as well, and then those two future climate exceedances, as well as the catchment phosphorus that I just mentioned. These were given scores of 1 to 3, so low to high, and they were either based on a sort of bespoke categorization in the project or on the percentiles across the distribution of the data. And that means that they're judged on this set of data. So it's low to high for this population of lakes. If we did it across the whole of Ireland, we could get a better idea of low to high for Ireland as a whole. Then we looked at the public and nature amenity values. So that's what I just talked about with the statuses. Are they designated as bathing waters, or drinking waters, or salmonid waters, and then lots of different protected areas, and the catchment population, how many people it impact, and then how big is the lake? If a bloom was across the whole lake, how serious would that be? Is it a really big lake? These were more simple. It was just a low or a high value. For the designations, 0 if it doesn't have it, 1 if it does, and for the others, it was just median, either side of the median. So this is the threats. So now we've got a matrix of all of those 11 metrics I talked about across the right-hand side there. Red if it's bad, green if it's not. And then these are ordered into whether they're similar to Lough Neagh in terms of their water chemistry. What you see is that you get some with a lot more reds than others. These aren't weighted at this stage. So if we took this further, we would look at weighting these. So what's more important? That might not be doable across the whole lake population. You might want to look at one lake at a time to do weighting. However, roughly speaking, sort of the top half are more worrying than the bottom half in this. But also, this is published in the report. You can have a look. It gives you an idea of the types of things that are problematic, whether it's the current conditions or the future conditions or the catchment and these kinds of things. And this gives us some idea of where we think these harmful algal blooms might happen. This is in exactly the same order as above. This is the public and nature amenity value. So if it's grey, it's been assigned a score of 1, of a high value. Now, because the top half were our more problematic lakes or more likely to have threats, the bottom half, you can see they're the ones with much more coming out in grey. However, if they're in the top half and they have lots of public and amenity value, you've got your Lough Neagh situation. So if you had a really serious harmful algal bloom, you would have a lot of people affected. It would make the news. We'd have to deal with it, and it would be something we'd have to learn to respond to quickly. To give that a little bit more understanding, we created this infographic. So we've got our HAB threat across the x-axis there increasing, and then we've got our public and nature amenity value going up the graph. This is just selected lakes, so that we could have chosen many in these categories, but it starts to give you an idea, as well as their statistics and their metrics and their scores. If you've got a high harmful algal bloom threat and a lot of public amenity value like we do in Sheelan, then that's something I would be much more concerned about than obviously one right in the bottom left there with a low threat and a low public and nature amenity value. And hopefully this kind of thing just makes it a bit clearer, gives a bit more understanding to the work instead of lots of tables and graphs. So a few conclusions from that data analysis. Firstly, that the exact causes and mechanisms of specific harmful algal blooms aren't generally understood. So we know a lot more about Lough Neagh, lots of work on it because it was so serious. But these blooms happen all the time and aren't even reported to us. People might not even recognize them. And we don't know a lot about exactly what causes each one. The main likely causes of Lough Neagh bloom are present at a number of Irish lakes. We highlighted them there. And that zebra mussel, that's the thing that perhaps tipped Lough Neagh over. So in terms of learning more about its numbers would be really important in Ireland. The statistical comparisons we did, we had to restrict them to sort of a spring-summer period over the last few years to get Lough Neagh's data and Irish data having enough for a statistical comparison. So it's useful to do it that way. We'd love more data, and there were no weightings used. So again, we could start looking at using weightings to get a better handle on this. The matrix I showed you of the threats, so some may have a number of factors. They might just be missing one, or they might just be missing two. So it gives you an idea of what might happen in the future and whether that would tip it into a big threat. It gives an idea of the lakes that are more concerning and why. And then those public and amenity values, these could be expanded as well. This project was only a few months long. If we had more time, we could add more in there as well and do a better analysis in that sense. Just to finish, the project had a number of recommendations through all of this work. As I say, this was published online yesterday, so please do have a read. Firstly, it's looking at a couple of things in terms of improving that evidence base we can work with. So increasing the monitoring of nutrients and other water quality parameters, particularly in winter, and trying to identify that clear water phase they saw in Lough Neagh before the spring-summer period. And increased monitoring or just recording of zebra mussels, so maybe people are finding them and not recording them, so increased monitoring of zebra mussel. Looking at updating policy as well, so looking at the uptake of programs of measures where they're not being uptaken, and if they're not included, put these high HAB risk lakes into the WFD priority areas for action. Two more. So actionable responses. We could develop a harmful algal bloom action plan for Irish lakes. So not just will it happen, but what happens if it does? And we can learn from Lough Neagh and other places around the world how to handle it. Maybe this report is showing that we're aware that this could happen. Then what do you do if it does? How do you handle the media? How do you handle the public? Also, there's useful citizen science tools. The Bloom and Algae app records algal blooms and was used really effectively at Lough Neagh, particularly as the event was happening and onwards. So that would be a really useful thing to be used in Ireland, could be integrated with the agencies as well. Then we get loads more records of when these things are actually happening. And finally, just to learn more lessons from Lough Neagh, such a big event, lots has been going on. They've got lots of projects going on to try and see if they can fix the problem or do something about it, as well as open and transparent approaches that I think we could learn from in Ireland if and when this does happen. I will leave it there just to say the publication has just been published yesterday. Have a look. Please do read it and get in touch if you want. I am here for the rest of the day. There's my email if you want to get in touch, and I'm more than happy to chat. So thank you very much.